Yes, 10 class students, that day we had studied about the reactions of combination, right? Today we are going to do the reactions of decomposition. I did explain, started something. Right now let's understand what is decomposition. Decomposition is defined as splitting of a compound into its constituents when energy is absorbed. Understood it? A compound has been split into two or more constituents. It is just the opposite of reactions of combination. What we have studied in reaction of combination, a number of reactants combine and we get a single product. That is what is known as reaction of combination. And here it is just the opposite. A single reactant split or decomposed to produce more than one product. And when this decomposition or the splitting into more than one product, that requires energy. So then that is what is defined as reaction of decomposition. So decompose means split, separated. Understood it? A compound is being split into its constituent parts. It can be elements or it can be compounds. And that is what is decomposition. So splitting of a compound or a single reactant breaks to produce two or more products is known as reaction of combination. Have you understood it clearly? Okay. This reaction of decomposition absorbs energy, which needs energy. Energy is needed for the reaction of decomposition. Now we can understand it. The energy that is available to us is in the form of heat, light, or electricity. And these are the three energies which can undergo a chemical change, which can make a chemical change. For example, potential energy is the energy possessed by virtue of its position. That means a stone is being taken, you place it up or place it down. The stone does not undergo any type of chemical change. If a stone is dropped from a height, it may break down to pieces, but stone pieces will remain stone pieces. There is no chemical change taking place. So potential energy and kinetic energy do not make any type of chemical changes. So the energy that is needed to undergo any type of chemical changes, either that is heat, electricity, or light. Clear? Three forms of energy. So first one, the decomposition by absorbing energy in the form of heat. That is, if heat is absorbed to undergo the decomposition, then it is known as thermal decomposition or thermolysis. THERMOLYSIS. Thermal decomposition or thermolysis. Have you understood it clearly? Decomposition by absorbing energy in the form of heat. For example, in metallurgy chapter, there is a term which is what is known as calcination. Calcination is a process by which when a carbonate compound is heated, it decomposes into its metallic oxide and carbon dioxide, and that is the meaning of calcination. You understood it well? So we can say that when any metal carbonate is heated, strongly, it gets converted into its metallic oxide and carbon dioxide, and that is what is calcination. So it is an example of thermal decomposition. Any metal carbonate, calcium carbonate, this is how quicklime is prepared. Tuna, this is a method of preparing it. What happens? These stone pieces are heated strongly, the marble or any type of stone pieces are heated strongly, then it gets converted into calcium oxide and carbon dioxide, and that is what is how tuna is prepared. So it is calcium carbonate decomposes to produce calcium oxide and carbon dioxide, and this is what is known as thermal decomposition. Understood it clearly? Yeah. Any metal bicarbonate, when heated strongly, it gets converted into metal carbonate, carbon dioxide, and water. Say, for example, baking soda is NaHCO3, sodium bicarbonate or sodium hydrogen carbonate. And when the sodium bicarbonate or hydrogen carbonate is heated strongly, we get sodium carbonate, that is washing soda, plus water plus carbon dioxide. That's a simple question. How one can get washing soda from baking soda? How one can get washing soda from baking? Simple process is this. Heating your baking soda strongly will give you washing soda. Or in other words, we can say any bicarbonate, calcium bicarbonate, when heated strongly, we get calcium carbonate, carbon dioxide, and water. And this is about the thermal decomposition. There are in the NCERT book, there is an activity given. When green vitriol is heated, what is green vitriol? I will explain the previous class. FeSO4.7H2O. FeSO4.7H2O. That 7H2O present in FeSO4 is known as its water of crystallization. Understood it? So in that chapter again, we may have to do, are these salts actually dry? Some of the salts have got water of crystallization in it. Some of the salts have got water of crystallization in it. Understood it clearly? So FeSO4.7H2O. Due to the presence of that 7H2O or due to the presence of this water of crystallization, ferrous sulfate is slightly greenish in color. Due to the presence of 7H2O, ferrous sulfate is greenish in color. Green means, don't just understand it this way, that a leafy green. It is a light greenish in color. Understood it clearly? And when that ferrous sulfate is strongly heated, what happens? First, the water of crystallization will say any compound which has got water of crystallization, when heated, the water of crystallization is lost. So what do we say? When FeSO4.7H2O is heated, that is green vitriol is heated, the 7H2O is gone. Now we have FeSO4. And when this FeSO4 is heated again strongly, it gets converted into Fe2O3, SO2 plus SO3. What is Fe2O3? Ferric oxide. Ferric oxide is a major constituent of rust. And what is the color of rust? Reddish brown. So what can we say? That when green vitriol is heated strongly, it gets converted into reddish brown Fe2O3. Understood it clearly? So first FeSO4.7H2O, when it is heated, it is becoming FeSO4 plus 7H2O. And FeSO4 is strongly heated, it gets converted into Fe2O3, SO2 and SO3. And in chemistry, SO2 and SO3, they say it has a smell of burning sulfur. Understood? When sulfur is burned, we get sulfur dioxide and trioxide. It has got a characteristic smell. We cannot say that pungent, irritating, sweet, whatever it is. It is mentioned burning sulfur smell. So what happens when green vitriol is heated? This is the thing which is taking place. Have you understood it clearly? On heating green vitriol, first water of crystallization is lost. Then FeSO4 is decomposed to produce Fe2O3, SO2 plus SO3. This is what is thermal decomposition. Understood it clearly? Thermal decomposition is also known as thermolysis. L-Y-S-A. T-H-E-R-M-O-L-Y-S-I-S. Thermolysis. That is decomposition by heating. Clear? The next one is electrolysis. Electrolysis or electrolytic decomposition. That is splitting of a compound into its constituents by absorbing electricity. In NCERT book, there is an activity given when we do the electrolysis of water. Water is H2O. Pure water is a bad conductor of electricity. To make the water good conductor of electricity, we acidify the water. Acidify the water means we put 2-3 drops of HCl, H2SO4, any acid can be added. If not, any soluble salt can be added. If not, any soluble alkalis can be. You have to make the water slightly impure. So here, what we do, 1 or 2 drops of HCl is added into the water. Then we place 2 electrodes are placed. One is connected to the positive terminal, that is anode. Other end is connected to the negative terminal, that is cathode. And these are attached to the battery. And battery means we don't attach it to the direct or AC supply. Alternating current supply, we need DC supply. So these terminals are positive and the negative are attached to the battery at the respective terminals. Understood it clearly? Respective terminal, whichever terminal you attach it positive, that becomes anode, and the other end, which is negative, will be the cathode. So cathode and anode, it is not clear. And then what happens? While passing electricity over these electrodes in that container, the electrolysis of water is carried out in an instrument which is known as voltameter, V-O-L-T-A, voltameter. Otherwise, it is known as electrolytic cell. When water is electrolyzed, it is known as voltameter, and for anything else, it is electrolytic cell. Say, for example, sodium chloride is to be electrolyzed. We don't call that as voltameter. We call it as electrolytic cell. Understood it? The electrolysis of water is carried out in an electrolytic cell, which is sodium chloride for that. And when water is done, the electrolysis of water is carried out an electrolytic cell, which is known as voltmeter. So it has got two electrodes, cathode and anode. Over the electrodes, two gas jars, or in fact, when we do it in a smaller experiment, you invert test tubes. Understood? Two test tubes are inverted over this cathode and anode. Fill it with water and invert. We are doing it in water, so there is no need you invert the test tube over these electrodes and place it. You see the activity that is given in the NCERT book. All right. And when the electrical switch is put on, wait for some time, we could see the bubbles are getting collected over cathode as well as anode. Understood it? And these bubbles on the cathode formed is double that of which is formed on the anode. The bubbles are getting collected over this cathode and anode, and these bubbles come up and they get collected in the test tube in the form of gas. As you know that when the gas is formed on top, the water will come down. Understood it? And say NCERT book activity, you see the diagram. Understood it? What is? I'll explain the entire activity once again. We are taken acidified water in a voltmeter or in an electrolytic cell which contains cathode as well as anode, which are connected to the battery with a switch. Over these electrodes, cathode and anode, two gas jars, we are inverted over it. If not, two larger test tubes are inverted over it. We understood it? And when electricity is passed, the bubbles get formed on the cathode as well as anode. You observe that bubbles minutely. And one could see for every two bubbles that is formed on the cathode, only one bubble is formed on the anode. The number of bubbles that are formed on the cathode will be double that of on the anode. And when these bubbles go up, they get collected in the form of gas. So over the cathode, a gas is collected, over the anode, a gas is collected. The volume of gas collected at cathode is double the volume of gas collected at anode. Two gases are collected. Now we have to test it. Which are these two gases? So the gas that is collected over the cathode is taken, and when we put a lighted mastic over it, it burns with a pop sound. It is a crucial experiment, and once you take out the test tube from that, the gas will escape. You have to do it very much carefully. Within the water, over the test tube, you put a glass jar, washed glass or something. It is getting filled, collected it, and then bring it out, and without removing it, light the mastic and slightly remove the glass, and the gas present in that burns with the pop sound. And the only gas that burns the pop, pop means pop. This is a sound that is produced is hydrogen. That's right. In chemistry, if it is says that the gas is burned with pop sound, that means it is hydrogen, no other gas. You understood it clearly? So at the cathode, we have got hydrogen gas collected it, which is tested it by burning. When a lighted mastic is put, it burns with a pop sound. Clear? And then coming back to the anode, the gas which is collected, you take it out. And if you put a lighted mastic, it burns more brightly. Understood it? When any burning thing is put it into that gas, it burns more brightly. And what does it show? Oxygen is the one which supports combustion. Understood it? Oxygen supports combustion. So when a lighted mastic is put into that gas jar or in the test tube, and if it burns more brightly, that means it gets more amount of oxygen. So on the anode, the gas collected is oxygen, and on the cathode, the gas collected is. So how the gases are tested it? Have you understood it clearly? That activity is very important. Many questions are asked from that. How do we make the, why should we acidify the water? Because pure water is a bad conductor of electricity. We need to make the water good conductor. Therefore, we need to acidify the water. The next one. What is the volume of gas collected it? The volume of gas collected at cathode to anode is 2:1. Anode to cathode is 1:2. Understood it? How are these gases tested it? The gas that is collected over cathode, that is hydrogen, is tested when a lighted mastic is put near it, it burns with a pop sound. And oxygen, it burns more brightly. These all. And when the diagram is drawn, make sure that the gas collected on the cathode will be double that of the anode. You have to show the diagram accordingly. And this is how. This is about electrolytic decomposition. In other words, we can say that any compound, say for example, sodium is extracted by the electrolytic reduction of molten sodium chloride. That means all highly reactive metals, sodium, magnesium, aluminum even, they get extracted. They are produced by passing electricity through their molten compound. You know how aluminum is extracted? Alumina, which is Al2O3. Alumina, which is Al2O3. Through alumina, that is molten alumina, we pass electricity. When electricity is passed through molten alumina, it is decomposed into aluminum plus oxygen. Clearly? The molten or solution form is needed. We have studied electrolytes. Electrolytes are compounds through which electricity can be passed either in molten or aqueous or solution form. Understood it? When sodium chloride solid does not conduct electricity, sodium chloride solid does not conduct electricity. Reason, sodium ions and chloride ions stay together. That does not allow the electricity to be flowed. And when the sodium chloride is heated, the molten sodium chloride contains sodium ions and chloride ions. So they are separated. So electricity to be flown, we need ions. Electricity to be flown, we need ions. So which are the ions? Na plus Cl. And when sodium chloride is dissolved in water, sodium chloride is soluble in water due to ionization. When sodium chloride is added into water, it gets converted into Na plus and Cl minus. You understood it clearly? So electrolytes are compounds through which electricity can be passed either in molten or aqueous solution. In molten or aqueous, they have ions. Understood it? Anyway, so why this water is electrolyzed? I told you this is how electrolysis. So all highly reactive metals are extracted by passing electricity through their molten compound. Sodium is extracted when we pass electricity through molten sodium chloride. You take common salt, sodium chloride, purify it, heat it to a high temperature. At high temperature, common salt melts, and you pass electricity through it, we get sodium and chlorine. So that is what is electrolysis. A compound is decomposed into its constituents. Now, metals up to aluminium are extracted by the electrolytic reduction. Metals up to aluminium are extracted by the electrolytic reduction. Understood it clearly? The next one is photolysis. So electrolysis or electrolytic decomposition, where electricity is absorbed in the form of energy. And the next one is photolysis. Photo means light. That means decomposition by absorbing light. First we have studied thermolysis. Thermo means heat. Lysis means decomposition. Next one, electrolysis. Electricity, lysis is decomposition. And the next one is photo. That means electricity, light is absorbed. Understood it clearly? There is a term. All silver compounds are stored in dark colored bottles and covered it with black paper. All silver compounds. So generally we say silver compounds are photochemicals. Photochemicals mean through the silver compound, when the light passes, it is getting decomposed. Any silver compound. And that is why the black and white photography, you know that. Black and white photography, the photography film is coated with silver bromide. When light falls, it decomposes into silver and bromine. So that is the photolysis. Understood it? Inside the book, there is an activity when silver chloride is taken and put it in a petri dish and leave it for some time. You can see it turns into black. So silver chloride is decomposed into silver and chlorine, or silver bromide is decomposed to silver and bromine, and that takes place by absorbing energy in the form of light. Therefore, that is known as photolysis. So thermolysis, decomposition by absorbing light. Photolysis, decomposition by absorbing light in the form of, energy in the form of light. Thermolysis, heat. Electrolysis, electricity, and photolysis, light. Clear about this? All those activities which are given in NCERT book, you should know it. Right? Let me take out some of these activities which is demonstrate the electrolysis of water. That is what is given it. Observation is important. The volume of gas collected is double. Hydrogen. Then they show the photolysis of silver chloride. That is activity which is given in the NCERT book. So it is getting decomposed. Silver chloride is decomposed with silver and chlorine by absorbing sunlight. Silver chloride is photosensitive. That is the reason. Clear? Photochemical decomposition, thermochemical decomposition, and electrolysis. Electrolysis I did explain. And thermal decomposition. Number of activities are given, like green vitriol is heated it. Then there is another one, but I mean to say that it is given in the NCERT book. Lead nitrate is heated, it is decomposed into lead oxide, etc. That is a reaction. All these things you should know. Understood it? 3 reactions over: thermolysis, photolysis, electrolysis. This is decomposition by absorbing electricity in the form of electricity, heat, or light. That is what is thermolysis. Clear? Thermolysis, electrolysis, and photolysis. Clear? When lead nitrate is heated, that is one of the reasons. It's also given an activity. When lead nitrate is heated, it is getting decomposed in lead oxide, nitrogen dioxide, and oxygen. You know, most of these so-called explosives contain certain nitrates in it, nitrates or chlorides and etc. Like gunpowder contains potassium nitrate. When any nitrate is heated strongly, it is decomposed into the respective oxide, oxygen and nitrogen dioxide is released. And you know that the oxygen supports combustion, so the rate of combustion will be increased many a time. That causes explosion. So when lead nitrate is heated, we get lead oxide, nitrogen dioxide, and water. And what is important? The nitrogen dioxide is the only gas which is brown colored. Any nitrate, for example, let's say copper nitrate is heated strongly. We get copper oxide plus brown colored nitrogen dioxide plus oxygen is released. You understood it? Lead nitrate is heated, we get brown colored nitrogen dioxide gas. This is all about thermal decomposition. All right. Next class we will take about the next reaction.